Hello and good afternoon for another tutorial for MS365 and all things data analytics and predictive analytics with Python. So if you're in class with me, hopefully today we can shed some light on a few things like finding the optimal value of K and dealing with categorical features. And if you happen to just stumble across and you need some help with Python, hey, welcome. Hopefully I can help you out. So let me set the scene a little bit and walk you through what we're working on. And what I've got loaded is our Titanic data set. For those that have not seen the Titanic data set before, it's basically a log and data information about all the people that were on the Titanic at the time that she sank. So we've got a bunch of columns in here that we have the ability to use as features, and one particular column that we will use as a target. So those particular columns are going to be if they survived, which is a binary column, the class, so that's like first, second, or third class. We have their name, which won't be super helpful. We have their gender, their age, if they are parents that had children on board. We had a parchment number, which I actually have to look that one up. We'll use that, but I can't remember exactly what that means off the top of my head. But we'll look that one up in a second. Ticket number, which is not particularly super helpful. We have the price that they paid, their cabin number, and the location that they left from. Okay, so those are all the things that we need in order to create some kind of classifier that we will use with Python. So what's the goal here? The goal is to predict a classifier that will tell us, based on all these different features, if this person is going to survive the sinking of the Titanic. And that's what's in this column here, the survived column, that is our target. So what we'll do is we'll do a little bit of exploratory data analysis. We'll do a little bit of data cleaning. We'll prep the data set a little bit to get things a little bit more usable, because what we want to do today is use the K nearest neighbors model. And that K nearest neighbors model is going to be pretty tough to use if we have something like a categorical variable that's just straight up words like this. That's going to be pretty tough to do. So we'll have to do a little bit of work with this. We'll have to make some transformations. We'll have to do some encoding. We'll have to do something in order to use all these different things and also use gender as a category. And additionally, since we know that K nearest neighbors uses Euclidean distance, if these features have to be on different scales, for example, the fair is on a different scale from, say, survived, we would have to go through and do some kind of normalization to make sure that they were all using the same scale, or we would have some issues that would happen. Okay, so let's just jump right in. So in the interest of time, what I'm going to do is I'm going to bring in a bunch of libraries. Now I'll talk about what all these libraries do, but just in the interest of time, so this is not an hour-long video, I'm just going to bring them all in sort of all at once. So what are the things that we are going to need to make this work? Well, first of all, we will need some of our sklearn libraries. So let's do from sklearn. We want to do some pre-processing. And the things we want to bring in are going to be the min max scalar, and something else we may or may not have the time to use today, we might just use GetDummies, but we'll see, is the one hot encoder. So let's go ahead and bring that in. All right. So from there, we'll need to bring in a library that would allow us to partition our data set, right? We're making predictive models, which means we're going to partition that. We're going to break it into to test, train, split. So in order to do that, I'm going to go back into my sklearn library again. Model selection, and I'm going to import my train, test, split option here. So that'll let us partition our data so we're not using 100% of it when we fit our model. So we'll need a few other things to make this work. So I'm going to give you a little look into the future. The data set is imbalanced. So since it's imbalanced, we're going to need something to sample or some kind of tool to help us balance that data set, since we know that classification models are sensitive to class imbalance. So what are we going to bring in? We will go from imbalance oversampling. We will import the random oversampler. Now I'll talk to you about why I did that when the time comes, but just for now, we'll say that oversampling will probably be the easiest thing. Smoke would work as well. And I'm not a huge fan of undersampling with data sets this small, because we're leaving potential training data just off the table. All right, so we've got that plugged in. So we've got 4 of our models. We'll need a couple more. What else will we need? Well, we will need to evaluate our model once it's made, and we will also need to make the model. So from sklearn dot neighbors, we are going to import our kneighbors classifier, if I could spell. And also from sklearn, we're going to do some model performance metrics. So we'll need accuracy score, and we will need classification report. And maybe just one more thing. So we'll import math, and I'll tell you why that is later. Perfect. All right, so we've brought in pretty much everything I think we're going to need in order to make some magic with this data set, or at least get us close. Now remember, the name of this video is finding the optimal value of K. So now that means that we're going to create a K nearest neighbors classification model. And once we go through and do that, we're going to create a loop that will help us figure out what the best value of K is in order to run this model. So here's what we're going to do. We're going to go through a quick process of getting the data prepped in order to create this K nearest neighbors model. Once we create the model, we're going to evaluate it, and we're going to see what we need to do to make it a little bit better. And one of the things we could do to make that better would be using something to help us figure out what the optimal value of K would be. So that's what we're going to jump in and do. So first thing we're going to look at is we realize, hey, we're going to want to probably use this gender column as a predictor. Now, why would I do that? So if you've never seen the Titanic before, you've probably at least heard this saying, women and children first. So women with children, or women and children, got a chance to get off the Titanic first. They got a chance to get in the lifeboats before everybody else. So it would be a good idea to potentially use this as a predictor, because one could deduce that you had a better chance of living if you were, say, a first-class female with children than a third-class male with no children in the bottom of the boat on deck D. Okay, so we're going to have to do some stuff to this particular column in order to make this thing work. Embarked. We might do something with that as well. Where you left from probably wouldn't impact if you survived on the Titanic, but you know what? Maybe it would. So we could fiddle around with that as well as potentially features we could use. Now, if you were to do more advanced things, we might want to play around with the cabin number. I think that could absolutely impact if you survived or not. C being the lowest level, A being the top level. But what you'll see in just a minute, if we do a little bit of exploring here, is we've got some nulls, and we know that nothing we do in this class likes null values. So we're going to have to do a few things to fiddle around with these null values. So first thing we want to do is we're going to want to get rid of the 177 null values that are in age. Why would we do that? Well, that's a lot of our data set. There's 891 records in our data set. So realistically, if we dropped 177, that's quite a bit. So what we're going to do is we are going to use this nifty feature called fill NA. So we're going to go df age dot fill NA, and we are going to fill this with the average age of all the people on the Titanic. And we want this to stay, so we will say in place equals true. Very good. So now if we were to run this cell above again, hey, we got rid of those. So that's doing pretty good. So now the 687 missing cabin tickets, that's going to be a bit of a challenge, probably more so than what we could handle in this particular video, but we could do something with this embarked right here. So I would say our best bet with embarked would be to just drop the two records that were missing, excuse me, on where they've left from. So there's a couple different ways to do that, but here is an easy way. So we'll say data frame equals df dot drop in A, and we will say from the subset embarked. Now let's talk about what that did. Boop, look at that, gone. So what did this do? So drop in A, you're probably pretty familiar with how that works, right? It's just the method that lets you drop null values from a data frame inside pandas. If you want to drop data set, or excuse me, records from a specific column, you have the ability to specify a subset. So what I did is I said, hey, look at the subset of just the embarked column and just drop those. So now right off the bat, I can't really do much with this 687, but the rest of this is pretty good. So with that, I am feeling pretty good about our data set. However, you know what? I'm gonna do one other thing since I'm not going too bad on time. I'm going to rename the column that's labeled sex in the default column to, how about we make that gender? So how are we gonna do that? We're gonna use another method. We're gonna go df.rename, and we're gonna say, hey, we want to rename the column that's called sex. We're gonna rename that gender. And what we'll need to do from there, and by the way, I did that using this dictionary method, right? So that's the key and that's the response value. What we'll do is we'll say we want access 1, which is the columns, and we'll say in place equals true. And now when we do this, look at that. We've replaced sex with gender. So things are cooking right along. So now if we were to look at this data frame, it's getting a little bit better, right? We've gotten rid of some of our null values. We've renamed a column, but our biggest challenge right now is that we want to use gender as a predictor, but gender says male, female, male, female. That's a problem. So what we're going to want to do is we are going to want to replace gender with a dummy coded version of what that would be. Okay, so how are we going to go about doing that? So we are going to use, in this particular case, GetDummies, but there are several other ways we could do this to make this work. So how are we going to do this with GetDummies? So what is GetDummies? Well, let me just do it first, and then I'll show you, and I will explain why GetDummies is probably not the best way to do this long term, but for this particular exercise, it'll be fairly quick and painless, right? So how are we going to do that? So we're going to say df equals pd.get, and we're going to say dummies. And what's up with GetDummies? What's that all about? So GetDummies is a method of dummy coding categorical data that is built into pandas. So you don't really have to do much here in order to make this work. Like, it's just automatically going to be there. You don't have to import anything extra. And you'll note that I did import the one-hot encoder earlier. That is for a more advanced way of encoding this data. And if I have time, I will show you how to do that. So what am I going to do? So I'm going to feed it my data frame. Okay. And then I'm going to tell it what columns I want to one-hot encode. And in this particular case, I want to one-hot encode gender. And I also want to one-hot encode embarked, although we probably won't use it, but I'm just going to do it. Go ahead and do it anyway. Actually, you know what? We're not going to use embarked in the interest of time. So we're just going to dummy code gender. Okay. So now there's a couple of things about this that I want to point out. So when I dummy code this, what's going to happen is anything that's a male is going to be 0, anything that's a female is going to be 1, or vice versa. So for example, male could be 1, female would be 0. So that's how it's going to indicate it. It's going to go in and replace them. Now, the way it's going to do it though, is it's not actually going to replace male with 1 and female with 0. It's going to create 2 columns. So there'll be a column that's called gender male, and there'll be a column that's called gender female. And in that column, the column gender male, if you are a male, it'll be 1. And if you're in the column gender female, there would be a 0, right? So it's called one hot because wherever the 1 appears in each one of those columns, that indicates what that particular record is. So now the thing about dummy coding things is that if we do this, we actually get collinearity, which we don't like collinearity. What does that mean? So if you have 2 columns, one that says gender male and one that says gender female, by default, in a non-politically correct world, if you have a 1 in the column that's gender male, then by default, you know what's going to be in the column that's gender female. So you don't actually need both. You only really need 1 because you have 2 columns predicting the same thing. So because of that, we don't want that collinearity. And what we're going to want to do is we're going to want to drop, excuse me, the first column of that dummy coding. Okay. So here's what that's going to do for us. Now, if I look at my data frame, check it out. So I have a new column called gender male, and it's just going 1 and 0. Now, what that means is if there's a 1, that means you're a male. If there's a 0, that means you're a female. Now, if you don't like the way this is working because it says gender male, you know what we can do? Well, we can rename that column, right? So we can do what we did before. So we can go df rename, and we will take gender male, which is lowercase, and we will rename that. gender, and we will say axis 1 in place equals true because we want it to stay. And now if we look at our data frame, we're really cooking. Perfect. So we've got some features that we can work with here. So what we're going to first do is we're going to create our predictors. And we'll just create a list of them, and just to make it simple, let's just do them all. So we'll do P class, and we will do age. We will do if they had siblings on the boat. We will do parch, which I will look that up and tell you what that means in a little bit here. We will do fare. That's how much they paid for their ticket. We will do gender, and we will leave off embarked in the interest. Perfect. So what does this mean for us? Well, this means that our X value is going to be our data frame predictors, and our Y value is going to be our data frame, specifically the column survived. So let's talk about why I did what I just did here. So I just created a list, and the list has got all the different names of the potential features that I want to use in the model. So once I did that, when I set my X and Y values, I have the ability to just type in predictors here instead of having to give it a list inside this data frame. So I could do this. I could take all of this list right here, pop it in there, and that would indeed work, but it's just easier to type it out this way. And then my value of Y is exactly the same. So at this point, we're not doing too badly, except this fare column here is on a different scale than everything else. So what does that mean to us? That means that we have to normalize our data. Dang. So what does that mean? Well, because KNN uses Euclidean distance, which measures the distance between 2 points, if you have observations that are on different scales, it's going to mess up the way that Euclidean distance calculates the difference between those spaces. So the best thing to do here is to normalize your data, and what that's going to do is it's going to rescale all of the features so everything is between a value of 0 and 1. Now, yes, back when you took stats class, you probably learned how to do this mathematically with pen and paper, but thanks to the world that we live in now, we have features built into Python and sklearn that can help us do that. That is where the min-max scalar comes into play. So what am I going to do? I'm going to use that scalar. I'm going to give it a name. There we go. And what I'm going to do is I'm going to create a new data frame called X norm. Now, it's not a data frame yet, but it's going to be eventually. So I'm going to use that scalar, and I'm going to fit and transform the value of X. Now, once I do that, here's what it's going to do. That's going to create an array. So if you're not familiar with arrays, this is an array. You're looking at one. And you can do things with arrays. You can look at the shape of it, for example, and it tells you there's 889 rows and 6 columns. So you're exactly where you want to be, right? We had 1, 2, 3, 4, 5, 6 predictors, and we had 889 rows. So we like that. The problem is, to just the everyday person, if you were to look at an array, yeah, it's just kind of hard to read, right? So most likely what you're going to want to do is take that array and put it back inside a data frame. And we can do that with the data frame constructor that you've learned about. So what is the data frame constructor and how does it work? Well, this is built in. So it's basically our ability to, make data frames using pandas. So what I'm going to do is I'm going to go pd.dataframe, and I'm going to feed it my X norm array that we just created. And I'm going to tell it that I want to give the column names the value of X. So basically, it's going to go up and use these as the column names. So now once I do that, if I look at my X norm df, I feel good, right? Everything's on a scale between 1 and 0. Everything's good. So at this point, we are in a space where we can partition our data. We probably are going to need to balance our data set, and then we will make our model. So what's the next step? What are we going to do? We are going to partition our data. Now, why are we partitioning our data? Hopefully you know this, but if you don't, When you work with explanatory models or exploratory models, you're going to use 100% of the data that you have in order to build a model that explains what has happened historically as best as you can, right? So when you were in stats class and you did linear regression, what did you do? You used 100% of all your data to try to come up with a line that best fit the R-square. You don't do that with predictive modeling. Because if you do, there's no way for you to figure out if the model actually has predictive power. There's nothing you can use to measure it, to test it, or to tune it to make it better. So when we work in predictive analytics, what do? We partition our data to help that happen. So what is that partition going to do? It's going to take, at this case, 20% of the data. It's going to take it, it's going to put it to the side. We're not going to touch it. We're going to just leave it alone. And then we'll use that to test or validate our data, our model, to see how well it performs on data that it's never seen. So now the importance of this is you have to take a random draw of 20% of your data. And yes, you could do that on your own, but there is a function that'll do that for you in sklearn, and that is the train test split function. So what are we going to do? We are going to take our x norm df. That's our x values. We're going to take our y, which we don't need to mess around with, right? We're going to feed it that. Then we need to tell it the test size. And the test size, in this particular case, we're going to go with 20%. What does that mean? So that means 80% of the data is going to be used to create the model. 20%, excuse me, is going to be used to test the model. So now the last thing we need to do is set our random state, because remember, it's a random draw. This could be any number you want. I'll just pick 8. Why not? So now when I do this, if I look at my X train, that's 80% of my data. And if I look at my X test, that's the other 20% of my data. So now we're cooking. So now this is when I would test you in class and say, hey, could we continue? But in the interest of time, since this is already a 20-minute video, I'm going to tell you, no, we can't. Why? This is why. So if I do my, let's do just my value of Y train. And I look at my value counts, what I find is that my data is imbalanced. So what does that mean, data imbalance? It means that, as we know, unfortunately, most of the people on the Titanic did not survive. And that's what it's telling you. There's 441 people in our training data that didn't survive, 270 people that did. So the problem with this is going to create implicit bias. And when I say implicit bias, what do I mean? I mean that it's going to favor predictions on the majority class, and did not survive is the majority class. So what does that mean? Well, if we're just looking at model accuracy, if we're trying to build a model that's as accurate as possible, when you're testing it, well, if most of the data is not survived, how do you make an accurate model? Just, try to predict as many as you can that are not survived. However, we want it to be more balanced than that. So because of this, we would need to balance the data set out, or it would favor the majority class. It would be really good at predicting that you didn't survive, but it wouldn't be as good at predicting that you did. So what we're going to need to do is we are going to imply some kind of sampling technique here. That could be random oversampling, that could be random undersampling, or that could be SMOTE, which is synthetic minority oversampling techniques. In the interest of time, I'm going to go with my favorite, random oversampling. So I'm going to create a variable, and I'm going to assign that to the random oversampler function that's built into sklearn. Now, with the random oversampler, if you leave it blank, this will work, but you actually can give it a random state as well. Okay. And now that we've created it, what are we going to do? Well, we're going to use it to oversample just our training data, just the training data. Remember, our testing data, that's like a control. We're not going to touch it at all. Not going to do anything. We're not going to fiddle with it. We're going to take it. We're just going to put it to the side, leave it exactly the way it is. So what am I going to do? I'm going to create an xtrain variable. So it's going to be called xtrain random oversample. And we'll call this ytrain random oversample. And we are going to use our random oversampler to fit and resample our values of xtrain and y train. Perfect. Now, if you want to test to see if this worked, here's what we do. We're going to go ytrain random oversample dot value count. There we go. Look at that. We've got a perfectly balanced data set. There's only one thing left for us to do now, and that's to build our model and evaluate our model. Now, that being said, remember the name of this video is finding the optimal value of K. That is actually what we're supposed to be doing. So instead of me just building a K nearest neighbors model and just testing it like normal, I'm going to show you how to create the optimal value of K. Now, there are a couple different ways that you can start with finding the optimal value of K. One kind of rule of thumb is that you can start with the square root of the total number of observations. That is one way to do it, and I think the answer would be like 27 to 30, something like that, based on this data set. But I want to show you another way to do that, and that is by creating a for loop to run through all the different possible options for the value of K to tell you what the best value of K would be to build this model. So we're going to do that by creating a for loop. So now here's what we're going to do. So I'm going to say for K in the range, and we'll say, remember I told you the square root of the observations is around 30, so we'll just make it simple. We'll say 1 through, we'll call it 40. Okay, what we're going to do is we are going to create a KNN model. So we'll say KNN equals K neighbors classifier. Okay. And remember, when you create the K neighbors classifier model, you have to actually specify the value of K. What is the value of K? It's the number of neighbors that are used to figure out the majority class for your prediction. So now, if I just use the number 30, it would look like this. Oops, not jobs. But instead of just using the number 30, I'm going to actually substitute that number 30 with that variable name of K, just like so. So it's going to loop through this over and over and over again. Okay. So now what else will we need to do? Well, we'll need to fit the model each time we do it. So we'll say knn.fit, and we are going to fit that to our X train random oversample and our Y train random oversample, like so. And then once we do that, we'll still need to create our estimates, right? So we'll say estimates equal knn.predict, and we'll take our grounded truth and our estimates. Now, this is where it gets tricky. So at this point, this isn't that different from just creating a model without looping at all. But what we'll need to do is two things. So first thing is I'm going to create a new row here. I'm going to move it up top, and I'm going to create a list that's just empty. So I've created a list called accuracy, and that list is just totally empty. Okay. Remember, you can do that. You can have a list that's empty. So what I'm going to do is, as this loop is looping through and testing all these different values of K, I need to put the outputs of that somewhere. So I'm going to put the outputs of this into this list. So how do I do that? So I'm going to say accuracy dot append, right? So the append method gives you the ability to add things to an existing list. And I'm going to use this dictionary concept. So what I'm going to do is I'm going to say, hey, I want to have an option called the K, and I want that to actually be what the value of K is. So if I were to just run this right now, it would literally just give you a list of 1 through 40. Okay, but I need more than that. So I'm going to need to have another option here called accuracy. And I'm going to let that use our accuracy score metric. And that will still require y-test and our estimates. And hey, you know, I made a mistake earlier that I need to go back and fix. My model predict is not y-test and estimates. My model predict is actually going to be x-test. That was almost a mistake, but we caught it. Okay. So we want to run this on our x-test data set, not our y-test and estimates. That needed to go down there. I was thinking ahead as I was doing it. All right, so let's cross our fingers and run this and hope we didn't have any typos. We did not. Perfect. So if we look at our list, here's what we're going to see. There it is. And look at that. We've got some like decent values in here. Do you see this? We've got some pretty decent accuracy scores right off the bat. Like we were in the 70s. Probably could use some feature engineering. Now that being said, how do you find the optimal value of K in here? Well, it's the one that's got the best accuracy score. However, it's hard to see with your eyes. So I'm going to give you a little bonus. What if we created a new data frame? So we'll just go df2. And we're going to put the values of the list that we just created inside that data frame. So this was called accuracy. Okay. Cool. So now it's a little bit easier to see. So what's our next step? How do we get the actual value of k? So what we'll do is we'll just use the max function. But to use the max function, we'll also have to use the location option. So what am I going to do? I'm going to do df2.loc, which is location. And as a quick reminder, what is that going to do for you? It's going to help you find a row that has the data that you want in it. So what I'm going to say is, I'm going to say, all right, well, I'm going to use inside my data frame, I'm going to find the location of my df2 accuracy when it equals df2 accuracy dot max. And if I've done this right and I don't have any typos, boom, it tells me that the optimal value of k is 4, which will give me an accuracy of 79.7, which we will round up to 80. So now what can that do for you? Well, all right, let's show you. So I can go back up here and I can cheat a little bit and steal this stuff right here. I'm going to jump down like so, and I'm going to pop this in. I'm going to take this value of k right there, and I'm going to replace it with the value of k of 4, which was our best set. Now, once I do all of this, I'll take these indents away. I have the ability to look at my accuracy and classification reports. So I will say print, and we will say accuracy score, and we will give that our grounded truth, aka our y-test, and our estimates. And then we will also do the same with our excuse me, classification report, and we will give that our y. I made another mistake, but I caught it. Y test and estimates, and I need to go up here and take these away. Those are not needed because those are variable names. And if we did everything right, how about that? That's looking pretty good. Now this could be better, and there are a lot of ways to make this better. The easiest way would be to go back and add some feature engineering. For example, you could do things like if they don't have any children on the ship, that means they're traveling alone. So you could add a new column for something like that. That could be a feet like, are they alone? Yes or no. So females traveling alone probably have a better chance of surviving. You could fiddle around with the cabins a little bit. The cabins are ABC, right? So this person is in C85. I do believe that those are the floors, but I could be wrong because I'm not a master historian of the Titanic. But you could fiddle around a little bit, and you could look at the A, B, and C tickets to see if those are potential features. But either way, you've got a pretty solid baseline to get you going. And hey, if you happen to be in class with me, I just did the homework for you. So hopefully this helps you out a little bit. If you have any other questions, please give me a shout. Hey, as those young kids say, if I helped you out and you'd like to see more, like and subscribe, and I will happy to nerd out a little bit more for you. So with that, my friends, I bid you adieu. I will talk to you soon.